Well, good morning, everybody. Here's the plan for today's forecast video. I'm going to spend just a little bit of time at the beginning here talking about the anatomy of this large complex of storms, which included many bowing segments that did a lot of damage last night coming out of Iowa, hitting Wisconsin, Illinois. And early this morning, as we watch overnight the infrared, we can see that the storm continues, and now it's spreading itself toward the Ohio River Valley, where it kind of comes together with where the Ohio River comes together with the Mississippi. We also have a lot of active storms still going in the Central Plains as well. And don't forget, yesterday there were storms in the southeast, those that rolled around the large Four Corners High, here, and then also into the northeast, where numerous severe weather reports were made. What we're going to do after that is we're going to walk through the influence of the Bermuda High and the Four Corners Ridge going forward. Once again, I continue to see this to be the mainstay of the pattern for a while. We'll stretch this out into a longer-term outlook where we talk about the hurricane season. We review the differences in the strength of La Niña from two of the major models, and we even take a look at what the potential for fall temperature and precipitation patterns might be. And just for the heck of it, I'm going to look at winter. Why not? It's Tuesday, one of my favorite days to record videos, so I'm excited to show you all that. Okay, so let's talk about the storm system here. Again, we've seen this now on satellite. It's pretty deep. And if we take a look at the radar animation, here is that squall line that rolled through parts of Iowa, into Illinois, into Indiana. And no, I don't know what's going on over here with the radar in Pennsylvania. But if you just watch again, you'll see two deep bowing segments. And numerous times as this storm system evolved along the leading edge of those bowing segments, we had rotation as well. So small spin-ups, and we did see some tornado reports from this. Now, with a large damaging squall line like this, which was capable of producing winds between 60 and over 100 miles an hour, I saw some reports of 117 miles an hour in both Illinois and Iowa. This storm just ripped through and did quite a bit of damage. Again, this goes right up through this morning, so you can see where the storms are this morning once this resets. And out ahead of it in Indiana, we had some pretty nasty storms as well. But here we go. That's this morning as to where the convection continues. I did take a quick look at poweroutage.us to kind of see where our power outages are. And I want to remind you that in Texas, we still have over 100,000, almost 150,000 still without power. And this was mostly from Beryl. Okay, and that was way back earlier in July. But in Indiana this morning, about 150,000. In Illinois, over 260,000. If I just click on my home state here of Illinois, we can kind of get an idea on those counties. I really want you to check out this site. It's a great one. It's just poweroutage.us, a great resource to kind of understand where we do and do not have power. But it comes down to the storm reports. And as you take a look here, let's blow this up just a little bit. As of this morning, we're at 729 reports. I made one of these reports in Mahomet just for this reason. I'll just show you a quick picture here. This is in my backyard. I have a shed back there. I keep an old car in the backyard. I love driving around. And this is not a tree I planted. So that fell out of my tree, and I don't know how it missed my power line and how it missed the shed. I'm very thankful that it did. But it's sitting there this morning, and it was too heavy. I couldn't push it off, so I'm going to have to climb up later on today and get this down. But that was just one of the many storm reports that we saw through here. And later on today, I have to drive to Chicago to fly over to Sioux Falls and eventually get to Pierce, South Dakota tonight. And I am quite anxious to see from the interstate what some of the damage is going to look like on the crops going through this area. So we'll try to do a little crop scouting this morning. But I thought you might find this interesting. I'm going to take you back to when I used to be a professor at the University of Illinois, and I dug up some of my old notes. And I'd like to show you a 100-level description of what a storm like this actually is. So if you've got a moment, let me just take you. It's one slide. I just want to show this to you. So the top of this slide shows the animation of the squall line as it rolled through Illinois. And so we call the bigger feature just a squall line. That's a nice generic name saying big, long line of storms producing some strong straight line winds. But this had many distinct components to it. Notice the little notch right in through here. We had numerous tornado reports. Tornado warnings out of that notch in a couple reports. There was a rotation on the northern side of this as the storm approached Chicago. I'm sure you maybe saw in the news last night that they put O'Hare under a tornado warning and sent everybody down to the basement. I got to go there later today. We'll see. Hopefully everything's all taken care of. But I let this just stop here to see where this line of storms, kind of on its ragged end down here at the south, kind of what it looked like as we went into the late overnight hours last night. Okay, here's what I want to do. I'm just gonna draw a line. We're just gonna cut through this thing. I don't know, something like that. And I'm gonna slice it like a cake and turn it on its edge so you can see it. And this is what the cloud field looks like. So the surface is down here. This big out, stretched cloud here, we call that the anvil. As we talked about yesterday, where the updraft slams into the stratosphere, we sometimes get what we call an overshooting top. But the storm motion is in this direction. Now, since this is a 100 level discussion, I'm not going to get too deep into the wind shear profile, but most of the time in storms like this, we tend to get what we call a unidirectional wind shear profile. So when you think about that, what that means is the change in wind speed and direction with height, you get more of a speed change rather than a directional change. Now, again, that's the basic side of this. But what that allows the storm to do is to generate its own lifting mechanism. And the lifting mechanism is what creates the updraft. So let me show you how that works. As the air is forced to rise, this is where it makes the cloud, and it makes eventually the precipitation through several different precipitation processes, both cold and warm rain processes. But the fact of the matter is on the backside is where all the rain is. Okay? So this rain on the backside, this is cooler air that's being dragged down because of its density difference toward the ground, and it's loaded with precipitation, meaning that it descends very quickly. And because of the way the pressure pattern, the mesoscale pressure pattern sets up within the storm system itself, you get this very fast back to front flow we call the rear inflow jet. And it's the rear inflow jet that descends into the storm, is then made to descend faster once it gets into the rain-cooled air that's forcing it to the ground, where it hits and spreads out. Some of it spreads out backwards, but the majority of it goes in the forward direction. It kind of kicks the legs out ahead of this. And what's interesting about it is when one of these approaches, the first clouds that you're going to see are way up high, real high, thin, wispy anvil cloud that becomes more of a cloud shield as it approaches. Then on the leading edge, you're going to get a shelf cloud. And that shelf cloud is typically your warning. If you see right here where I'm hovering, that is where the shelf cloud was as it went through Springfield last night. Now, no one probably saw it because it was after sunset, but many pictures yesterday showed this. So I'll show you a picture of a shelf cloud in just a few moments. But what I want to tell you about it is when that shelf cloud comes passing over you, that is when you tend to get your strongest winds. They tend to really come accelerating out of the back of the storm. There's a major drop in temperature. And then you get into the main downdraft. This is where most of the lightning is. And then following it, usually for, sometimes a couple minutes, sometimes a couple hours, you get what's called the trailing stratiform region. This is this broad area in the backside where there's just lighter rain and oftentimes a lot of lightning and thunder. But I would like to show you what this looks like. So let's go and have a quick look at the front edge of the storm because I had several people that kind of tweeted it to me last night. And so we come back here. Let's go and make this large so you can see all of this. I'm going to go to my Twitter feed. Troy Dukes, he grabbed a picture of what that shelf cloud looks like. Now remember, when you see that shelf cloud, it's all bark, no bite. It's telling you, listen, what's behind me you're not going to like. And so when you see this, snap a picture, but then very quickly you need to get inside and take shelter because it's going to race over the top of you, sometimes speeds 60 to 100 miles an hour, and what's behind is going to be pretty nasty. I had another one that was sent to me. I'll kind of blow this one up here just so you can kind of see this a bit better. Josiah, beautiful view of the shelf cloud. I'm assuming lit up by lightning here. And this will be the thing that I'm going to be looking for is how did the corn stand last night? How did the beans look this morning? We'll have to make sure we get some scouting in on my way up to catch my flight over to South Dakota later today. So just incredible to see these pictures and to understand how the storm structure looks. But it's one where the outflow dominates the longevity of the storms. And that's what we're still seeing. So the rain that came from these through 6 a.m. this morning, very, very heavy rain from multiple storm systems. You can see the northwest flow. In fact, this is it, right? We have a Four Corners Ridge. We have flow that's coming out of the northwest, and we have the Bermuda high feeding. That is going to be the mainstay of our story going forward with time here. But these storms just continue, and this is what I meant by the outflow being dominated, because after yesterday's, nearly 500,000 cloud-to-ground lightning strikes, the storms are continuing down here into parts of Missouri, into southern Illinois and Indiana this morning. Now, speaking of lightning, as you look at this image, while it was a lot just here in the last 24 hours, take a look at the western United States. Lightning this time of year can be a massive problem in the western United States because oftentimes we have thunderstorms that are so high-based that their rain never hits the ground, but the lightning can. And the lightning can also initiate fires. So if we just have a look yesterday at the satellite data as we watch the monsoonal surges of moisture create these huge storms lifted by the mountains. You can see late in the day as the sun sets the smoke that's from the wildfires in Oregon, also here in Washington, spreading over into parts of Montana where there's a large fire. But the one that really caught my attention is this one right here. You'll see as I animate this that smoke plume almost detaches a bit from the fire. You can see its shadow very clearly here, and it just moves out of Oregon into Idaho yesterday before the sunset. So we're going to have to continue to watch the wildfire threat in the west as the big Four Corners Ridge starts to rebuild. Now this morning, about 6:40, the temperatures were starting to reflect the position of that cold front down into the 50s across the upper Midwest. It's still hot to the south and very hot to the east, and heat will be rebuilding to the west. But the reality is the cool down that's beginning to happen here is going to press through the rest of the Midwest into the south and eventually into the southeast and east with time. It's just going to take a few more days to get there. But there is a cold front. And as this resets, you can see that by midday today, it's going to be sitting right in through here. Can you see on the back side the flow coming in like this? But the mainstay of our pattern is the Bermuda high, and it's just ready to feed into the southeast. We're going to see how that's a critical part of this upcoming pattern. So again, where are we this morning? Watch this animation, which will go up to about the time I'm recording. The storms continue to support themselves, feeding into the unstable air here. And we've got a lot of active storms. You can just see on our latest lightning tracking by Blitzertung, fantastic website, just showing us where the storms are in Kansas, Missouri, Illinois, Indiana, isolated storms around the eastern Great Lakes, storms that are coming right now through where I should be tonight, heading toward Pierce, South Dakota. Maybe later on today we'll be able to see if we can get some storms in this area. But here's your all hazards map. So we have the flood watches that are out, severe thunderstorm watches, and there's a warning in here. The heat is to the south, the heat is to the east, and the west. Starting to see these heat advisories, air quality issues returning in this area. Also, take a look at parts of New Mexico where there are flood watches posted for today. Severe storms today, primarily going to be in Nebraska, Kansas, down toward the panhandles, parts of Colorado, and then again in the Northeast, where even though I focus on the storms that were in the Midwest, we saw numerous reports, take a look at it again, that were in parts of Pennsylvania and into New York and several surrounding states here. So given that, let's go ahead and have a look at the day 2 forecast, which you can see rolling up the East Coast, another day of severe storms. We go back to the high plains, and what this will be again is all along the position of the front, which will kind of be lingering somewhere like that across the country. High-res NAM picks up on this. Let's just play it through the middle of today into tonight. So again, we're going to watch this area and here for the risk of the strong to severe storms, and also into the Northeast. And then as we get into tomorrow afternoon and evening, watch it carefully through here. Watch the frontal boundary linger, giving us the risk of these storms, possibly some storms in the mountains up in parts of Washington, Idaho, and Montana. But by the time we get toward the end of this week, that front really tries to clear through and knock temperatures back, bring in some dry air, which we've been watching carefully. So how much are we expecting out of this? Well, if we just play through the high-res NAM all the way out there to midday Thursday, drier air is coming in here. We still have the storm activity through this region, but it's important to note where the storms are not getting to just yet. And we notice this larger hole that's right here in parts of Oklahoma and Texas. Thank goodness there were storms earlier today in this part of Kansas, but there's scatter storms coming into some of the drier pockets we've been paying attention to. And what I just noted there was that this same dry area doesn't seem to be able to grab a whole lot of moisture out of this storm complex coming through, but possibly we could increase the chances here. And with the Western Ridge rebuilding, we do expect this to continue to stay dry, but isolated thunderstorms rolling around the periphery of the Four Corners Ridge seems to be the mainstay of this pattern as we go forward. So, taking a closer look at that southeast region, I'm really just going to watch as the models attempt to fill some of this in, not just now, but into the future. And here's kind of the bigger picture thing for the next 15 days. This is very much dominated by 3 features. The first, Four Corners Ridge. The second, the Bermuda High. The third, kind of the increased frequency of troughs that kind of follow this trajectory. So what you end up getting here is fronts, flow coming over the top, and flow coming around the bottom of these 2 big ridges. And that's why the 14-day outlook from the European ensemble from this morning continues to show above average precipitation for almost the entirety of our cotton belt, except for what we grow farther into the southwest, and just a big section here of the south, southeast, even up into the Ohio River Valley and the East Coast. All of this without a tropical system. All right, there's no tropical system being forecast with this. So this is what it looks like. European ensemble. We play this forward. There's the western ridge that rebuilds. This is by Thursday. Deeper trough digs in, bringing in the cooler weather. Getting into the weekend, there's the western ridge. We just keep seeing this. There's the trough that comes down the eastern side of it. There's the Bermuda high feeding. And that pattern seems to go on repeat in the models. In fact, it gets quite deep out here about a week from now, next Tuesday, with a trough that's sitting over the kind of Oklahoma, Kansas, Missouri, Arkansas area. And I'll show you the temperatures of that in a few moments. But even if I take you out there 11 days, there's a ridge sitting here. There's the Bermuda high, and there's the trough coming in. We seem to be kind of trapped in this pattern for a little while, and it's also reflected in the AI. It's reflected in the GFS, which is why most of these forecasts are going to look quite similar. One thing did change, though, was we blend the entire 15 days together. So this is still very much there, and there's our Bermuda high, okay? But the extent of this trough that gets into Europe, I want to take a look here at what this might do to precipitation over here in this part of Ukraine and Russia. In fact, let's just go bring that up real quick now. Let's just go to ag weather. If we slide down to the precipitation forecasts, we can see the global map right here. And what was interesting was we started to get more storms in Central Europe, more storms in Western Russia. That's been a bit of a break away from where we had been as of late. There's still dry pockets in Ukraine and Southern Russia here, but still better chances, I think, of getting some storms as we go forward. Okay, so that brings us back to the U.S. Let's go ahead and do our quick 5-model tour. There's the artificial intelligence system. It's forecasting the next 7 days. This is the national blend of models. It's the same story we've been going through here. This is what the WPC is showing. Here is the 0Z European. Now remember, a lot of this rain you see into this area was complements of last night. And here's the 6Z GFS. I see a lot of the same in each one of these forecasts. And maybe we can distill that down as I normally like to do with some probability maps. So using the 0Z run, so this does include some of the rain from last night in it. You've got the next 7 days best chance at an inch. And you can see the influence of that Bermuda high here. And if we stretch this out to 10 days, right there, it's pretty high. In fact, if we step it up to 2-inch probability, I mean, this is hitting that one spot that I've been so concerned about that's been dry. We've got to get the moisture back into this area to just continue to relieve the drought that's been growing in this region. Okay, I would like to compare the models for you quickly here. GFS left, European right. As we play this forward, we've seen through Wednesday and Thursday as the front sags. Now, as we go forward, you're going to notice a couple of things. The Bermuda high pumps in, but you will see by Saturday into Sunday a weak little system try to show up in the midsection of the country. And that's a part of this next trough that sags into this region, possibly delivering some rainfall into this area. But overall, we just play this forward, and I take you all the way out there. This is next Wednesday, Thursday, Friday. You can see the influence of the Bermuda high just producing daily rounds of storms here, kind of running into this kind of semi-permanent frontal boundary, and the potential there for 1 to 4 inches of rain is pretty high. Watch it all and fast forward here. Ready? This is Tuesday today, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday. Do you see that? It's kind of this pattern that's on repeat as we go forward. And if we look at it out there into the 23rd through the 29th, we continue to see the influence of the flow coming around Four Corners Ridge. This is all going to be due to monsoonal flow. And then around the Bermuda high right here. So these are 2 narrow corridors that have the potential for being wetter than average. On the temperature side of it, I showed you the drop in temperatures, but take a look. Heat in the northwest today. That's why all the heat advisories are still posted here. Hot in the southern plains, hot up the east coast, but that front continues to press through. So while Wednesday stays very hot in the northwest, cooler air is diving into the midsection of the country by Thursday. Highs around 76, where I live here in Champaign. Heat's still in the west. The front clears all the way down to the south by Friday, getting into Saturday and Sunday. In fact, this weekend I'll be down in Florida for a conference. So I'm going to leave the beautiful weather here and head down to the scorching temperatures around Jacksonville. That'll be fun. But then there's Monday of next week. And that's why the day 5 through 10 shows this. And there it is. That is your pattern. My goodness, this is pretty well telegraphed. See it? That's the pattern we're in right now. And if we slip over to the day 10 through 15, we see the same kind of setup. And the European model agrees. That's out to day 10 through 15. So thinking all of this through, you now got a better idea, I think, of what's coming. Why don't we just step it out and try to look a little bit longer beyond this to see how long this western U.S. heat lasts? Because NOAA, again, yesterday issued from the 23rd to the 29th the risk of getting repeated rounds of excessive heat into this area. So thinking that through, I'm going to give you an analysis of ocean temperatures. And the main things I've been watching. It's the warm water flanking North America, underneath of which we've had two large areas of high pressure. But the warming trend that's happened in our PMM region and in the PDO, this part of the PDO signal, is what's taken the risk of a central U.S. ridge over to a Four Corners ridge. That's kind of historically what happens. Now, in Niña region 3.4, which is here, we are sitting at INSO-neutral conditions. We're waiting on big surges of trade winds to hopefully come later in fall and winter to give us the kind of initiation of a La Niña. But we do have a few bands of cooler water here, and there's some cooler water lingering under the surface that could come up to the surface if we get some stronger trade winds in place. But over the next month, I'm just going to look at August here. We do notice that I think it's still the Pacific high, which sits here, and the position of the Bermuda high that are going to dominate things. And what I see is that the Pacific high has now seen higher than average, that's the warmer colors, higher than average pressure living here. And that's going to help West Coast ridging. And that's going to force the jet stream to drop here and then pop back up, and the flow will come around the southern side of this. We do note in August that the models have been dropping pressure coming off of Africa, indicating more activity in our tropical season. But just to kind of zoom in and show you what this might mean for the U.S., let's take a look at the 30-day precip for August. And while it does suggest drier, possibly drier in the plains and the Canadian prairie, just because of its closeness to that ridge, I still think we get storms that cascade over the top of this. Certainly expect this area to stay stormy given the Bermuda high and its influence. And temperature-wise, I don't think we'll see any surprises here that if you're close to that larger ridge, more often than not, you're going to see above average temperatures. So plains, Canadian prairie, and the west. With this pattern, when will we start to see more activity in the tropics? Because right now things are pretty dead in the tropics. I think we're going to have to wait on some sort of a shift to get away from the suppression in the upper atmosphere we're expecting all the way through the end of July to be sitting here. It's probably going to take some sort of convectively coupled wave to move out into the Pacific to knock this out, and it just may not happen for the next 15 days. It may take more time than that for this to occur, but there will be something to upset this pattern in the tropics, which will get it going. The Colorado State University, which again considered some of the best in the business at forecasting hurricane seasons, they did update this on July the 9th, so last week, and you can continue to see that in every category they've got above average, well above average, in some cases nearly double what the typical numbers are. Just remember that when we name hurricanes, we only use 21 names on our name list. We don't use Q, U, X, Y, and Z. So to say that we might have 25 named systems this year would mean we'll go 4 letters deep into the Greek alphabet. So we're still waiting on this tropical season to get going. One of the big influences of this will be the evolution of La Niña. You say, why? Well, when La Niñas occur in the Pacific, they tend to reduce wind shear in the Atlantic. It's all one big connected system. And if you just take a look, our two kind of main forecasting centers, ECMWF and NOAA, their flagship models, well, the European model's not aggressive on the development of La Niña. You can actually see it's INSO-neutral, whereas the CFSV2, which is one of the models that NOAA runs, is much more aggressive on this. And the difference is pretty clear. If you look at the ECMWF's forecast for September, October, November, active hurricane season, that's what all this green is. But maybe a little bit more wishy-washy on who's going to be drier in the midsection of the country. And do we get a wetter fall across the northern tier here? That's a big question mark. You compare that to the CFSV2 for September, October, November. Again, it's only showing over land, but we are expecting an active hurricane season. But it's a bit drier into this corridor, and it's beginning to show an early onset of moisture coming into the northwest. And one of the reasons for that is that when we have La Nina developing, we tend to develop a stronger more north trended jet stream pattern. And I'll show you the influence of that in 1 second here. But first, what about the temperature outlooks? Warm fall. That's what most of the models are calling for, September, October, November. And many need a warm, extended fall in order to get things finished, to get the crop to finish without having risk of a frost, to then get application done. So I was looking at that yesterday, and I made a couple of correlation graphs. First, I showed you this. This is the comparison, 7 different models, remembering that NOAA is the most aggressive on developing La Nina. But if you look historically in the month of October, and you make a correlation map of ENSO and temperatures, you get this large area of blue shading, which represents a negative correlation. Now what that means is if there's an El Nino, this tends to be cooler in October. If there's a La Nina, you need to take the inverse of this. So that's why I put up here. In La Nina, blue means warmer than average temperatures. Okay, so just understand it's a correlation map with a red-blue color bar. It's okay. We're just going to interpret the colors properly here. So right now, La Nina tends to produce a warmer autumn for a big section of the Midwest, Great Lakes states, and Northeast, and a little cooler in the West. Precipitation-wise, when you look at this, the warmer colors represent drier than average. So the Northwest tends to get wetter sooner, whereas the South tends to stay drier. And if we think about this longer term, this is what happens when you get into winter if La Nina dominates. We tend to be much colder to the north, much warmer to the south. And what does contrast in temperatures where it's hot south, warm north do? It drives a much more powerful jet stream across the country. And what you end up getting for most of winter is something that looks like this. So, a lot hangs on La Nina becoming the dominant feature, but we don't know yet if it's going to do that. Some of the forecasts are much, much weaker in the development of La Nina, and that's just something we're all going to have to watch together as we go forward. So, that's what I got for you today. I'll talk to you again tomorrow morning from Pierce, South Dakota, and we'll chat a bit more about this pattern and where it might take us. But with that, I'll stop it here. I appreciate it. Thanks.